Well, let's get started. First off, thank you for coming to hear me speak today. I appreciate the opportunity to be here. So we're going to talk about GraphQL-based microservices in Elixir. But first, I just want to introduce myself a little bit. So I'm actually a Colorado native. I was born and raised in Littleton, which is about 45 minutes from here. So it's good to be back home. I have a wife and a daughter. There's a picture over there for you to see. I've been a software engineer for about 3.5 years. And I've been with Podium and working in Elixir for about 10 months now. Started last October. So a little bit about Podium. We're an interaction management platform, and we're modernizing the way that local businesses communicate with their customers. We're all wearing this same shirt today. There's a lot of us here in the front row as well. Feel free to talk to us about Podium, ask us questions. We have a booth over there you can go check out as well. So that's my little plug for them. It's a great place to be. So come learn more about us. All right. So there's a few key takeaways that I want you to be able to walk away from this talk today and have a better understanding of. So the first one is I want you to understand the benefits of using a microservice architecture and why you might want to use it to choose to use a microservice architecture versus a monolith architecture. Second, I want to go through the backend for Frontend, BFF for short, benefits that you can use with a microservice architecture. It can be a really powerful pattern, and we'll walk through that. Third, I want you to understand GraphQL and the benefits of using it and why you might think about using that for communication between your microservices. And then since this is ElixirConf, we have to talk about Elixir, right? And so I want to go over how you can leverage all of the above in Elixir and some implementation of these concepts. So first off, why microservices? So how many of you have ever started a new job, maybe switched teams at a big company you were at, and you had to dive into a legacy app, and you felt a little bit like this? You're confused. You don't know what's going on. It's hard to follow the code paths. You don't know how anything's happening. It just feels like magic is everywhere. This is a really common problem when you're diving into a new code base, at least new to you, in these legacy systems. And this problem can be made manifest when you're working in a monolith, because as the business grows, the code base grows, it becomes more and more complex, and it becomes more and more difficult to work in. And so microservices can help mitigate this problem. And so essentially what you do is instead of having a monolith as shown on the left here with your UI and your business logic and everything all living together, you just break it out into pieces. And you have individual pieces of your business in these microservices. And one of the great things about using a microservice pattern is you can have autonomy with your teams. It gives you room to innovate within your company, to try new technologies, to try new languages. So in this example, you could have team 1 that's using Python, and then team 2 that's using Go. And you can have whatever kind of configurations within your teams. You can have your own code standards within your teams. And that can be really powerful because as developers, we love our autonomy. We love being able to make decisions. We love being independent on our teams and being able to innovate. So that's a really big plus for microservices, is it allows for that team autonomy. Even if you're all using the same language, teams are going to have different thoughts on patterns within the code, and it lets you to explore those. Another really big pro with microservices is it allows greater fault tolerance within your application. So if you have a single monolithic app, and then that monolithic app goes down, you're going to lose all of your services. But if you have microservices and it's broke out into different pieces, if one microservice fails, you can still deliver a partial service to your customers. And that can be a really powerful thing to not have your entire app go down when one service fails. It can really help with readability and separation of concerns. I don't know if a lot of you, when you first learned programming, if you learned about functions. When you write a function, at least what they told me was the function should do one thing, and it should do it well. And you can think about that same concept with microservices. A microservice should own one piece of your business, and it should perform the actions for that piece of your business really well. And if you think about it like that, it makes sense to break out these pieces so that it's more readable. It's easier to follow the logic within these code bases. There's going to be less of these magic pathways that you see. And so that can be a really powerful reason to use microservices as well. It also allows for ownership to be clearly defined. As your business grows, you're going to have more and more engineers, and it's important to know who owns certain pieces of code and who's responsible for them, just for responding to incidents, whatever it may be. So these are some really powerful benefits that come along with using microservice architecture. And I wanted to throw in this picture of developers working on a monolithic repo. Because when you're all working on one monolithic app, it can be really difficult to not step on each other's toes and feel like there's too many cooks in the kitchen. So this is another reason why using microservices can be a benefit to your business. But I say some of this tongue-in-cheek. Microservices can have their own issues, and they're not always going to be the answer to everything. It's not going to be the be-all, end-all solution. And there's definitely a use case for using monoliths. Oftentimes when businesses start, they start with a monolithic pattern because you're still working on an MVP and you're trying to be rapid, and it doesn't make sense to go through the overhead of deploying multiple microservices right off the bat sometimes. So there's definitely a time and place to use monoliths and a time and place to use microservices. One of the cons is that it adds complexity. Even though it's simplifying some of these code bases, it's going to add architectural complexity to your business because you're going to have to understand how these microservices communicate with each other. You're going to have to define the contracts between them. It's also going to add some deployment overhead. You're going to need to make sure that all of these apps are deployed properly and that those communication channels between them are all stable and work. And that's going to just be an additional thing to worry about. You need to make sure you're not having circular dependencies and having microservices affect other microservices that go back to the original one that kicked off some task and have that continuous loop, because that can cause really bad issues. The other thing is you need to have those good boundaries, and that can be a really strong argument for starting with monolithic and then moving to microservices, because as your business grows, you're going to understand those boundaries better, and if you guess those boundaries wrong when you're starting off with microservices, that can be really detrimental and really difficult and expensive to go fix later. So those are some of the cons of microservices. And there's tons of information on the web about microservices. Here's a few links that I thought were pretty good that you could go look up if you want to learn more. So the first two are just some pros and cons lists that go through why you might and might not want to use microservices. And I thought the third one was kind of interesting. It had some real-world examples of companies that have gone through that transition from monolithic to microservices. I think Walmart was in there, Amazon, and I thought that was just kind of an interesting read to see how these different businesses went through that process. All right, so now let's talk about backend for frontend, or BFF architecture. And if you're unfamiliar with it, I wanted to start off with just a few definitions. This first one comes from IBM's website. It says the key component of this pattern is an application that connects the front end of your application with the back end. So essentially, you'll have your UI piece, and it will only talk to one single back-end microservice. And that microservice is going to handle speaking to all the other microservices within your system. And here's another definition that comes from Microsoft. It says create one backend per user interface, fine-tune the behavior and performance of each backend to best match the needs of the front-end environment without worrying about affecting other front-end experiences. And I think that's important to remember, that each user interface should have its own BFF. They shouldn't be sharing BFFs, because the goal is to fine-tune this BFF to be built for that UI experience and deliver what it needs in the best way possible. And I think a visualization can be really helpful here. And it's really not that crazy of an idea. You're just replacing that image we saw before, and the BFF is the only line of communication between the UI and the rest of your microservice ecosystem. And so what are some of the pros of doing that? Well, first off, you're going to have less contracts on your front end. Front ends can be difficult because you're thinking about event-driven kind of development, right? Users have actions that they're taking. You're having components that you're rendering. There's all this other stuff going on, and so the less contracts you have to manage, the better it can be for your UI, and the less confusing it can be to follow. So at Podium, you use a lot of React, and we use Apollo, and we use GraphQL. And in Apollo, you have to set up a provider that speaks to a certain backend. And if you have 10 different backends that you're speaking to, that means you have to have 10 different providers that are all nested, and that can be really gross with your components and things like that. And so this helps to mitigate that problem as well. Another really powerful thing that a BFF can do is it can serve as a translational layer from your business logic to your UI. So a common use case that we have on the front end is maybe we show or don't show something to a user based on some permissioning they have, maybe the role they have in our system. And so the BFF can serve as a translational layer between the UI and the rest of our microservice. So imagine you have this button, and you want to decide whether or not to show it. Then your BFF can tell your UI, hey, show this button or don't show this button. But maybe behind the scenes, there's some logic in some microservice that says they have a certain role within your system. The BFF can make that translation from that role to showing that button or not showing that button. And then even if the logic on the back end changes for whether or not you show that button because you break out into a new microservice or something like that, you don't have to change that contract between your UI and your BFF. And that can be really powerful. And in the same vein, it allows you to more easily add new microservices. Like I said, if you need to break off a piece into a new microservice, then the BFF can just point at that new microservice instead of the old one it was pointing at, and those contracts aren't changing on the front end. And that can be especially important when you're doing mobile development. Mobile development has a slower release cycle. We have to push updates to the App Store. We have to wait for users to download those updates. And so the more we can do on the back end without having to push those updates, the better it is for our users, because they're able to get live updates faster through that BFF. And we're going to walk through a more specific example of that in just a minute. Now, there's going to be cons to using a BFF as well. So one of the biggest one is a duplication of code. So if you have your BFF has certain endpoints that your UI is hitting, sometimes you won't really need a translational layer. Sometimes it is going to be the same call to that other microservice within your system. And so that's duplication of code, which is always a thing that we try to avoid, right? And so that's one sacrifice you have to make with the BFF. And then again, it's going to add additional architectural complexity. Any microservice you add to your system is going to add complexity to your system. It's one more thing to worry about, and so that's something to consider when you're thinking about the BFF pattern. So let's look more specifically at this example of mobile development. We kind of talked about this, but I just want to reiterate it. So say you have your mobile device, and you have some kind of app, and it allows users to update their profile and to search for blog posts. And then you have your BFF that has the endpoints for your UI to hit for that. And then it hits some monolithic app or some old microservice for those two actions. Typically, if you wanted to update those calls, you would have to have the UI change to hit new microservices. But with the BFF, you don't have to change those contracts at all. They just can stay consistent between the UI and the BFF. And that can be a really great thing for your users and for you, so you don't have to worry about the slow release cycle. And if you're thinking about moving from a monolithic architecture to a microservice architecture, putting a BFF between your monolith and your UI to begin with can be a great way to help you break out into those microservices to begin with, because then you're able to make those changes more easily. So there's a ton on the web about BFFs as well. The Sam Newman article, I think, is one of the first posts on BFFs on the web, and all of the other articles reference it, so that's a great read to kind of learn about this pattern. IBM and Microsoft, who I stole those quotes from for the earlier slides, they also have some great documentation on using BFFs, and if you want to learn more, I highly recommend checking those links out. All right, so let's talk a little bit about GraphQL. So GraphQL is relatively new in the past couple years, technology from Facebook, and it's a replacement for typical REST APIs that you would create for your applications. And there's a few reasons why you might want to consider using GraphQL. And the first off is that you can dynamically retrieve only the data you want. So with a typical REST endpoint, you're going to hit /users with an ID or something, and you're just going to get the fields that they return to you. Whoever designed the API gets to dictate those fields, and if you want something more or less, you have no power over that. You're just going to get everything. GraphQL changes that by letting you dynamically say what you want to get it when you want it. It has a self-documenting API. I'm sure all of us have dug through REST API documents before, trying to figure out how to get the data that we need, and it's not a fun experience. But with GraphQL, they have a type system that makes it super easy to explore the API of a GraphQL service, because they just have a single endpoint that allows you to explore that type system and see all of the fields available on the root, and you're also able to see all the subfields that you can request off that GraphQL schema, which we'll talk about more about schemas in a second here. And the third really powerful thing that it lets you do is reduce network requests. So typically, if you wanted to grab a list of users and a list of blog posts, you'd have to make 2 separate requests to 2 separate REST endpoints in order to get all of that data. But with GraphQL, you're able to get all of that same data in just one single request. And so that's going to mean faster applications because less requests on the front end. So let's talk a little bit about the basics of GraphQL and what it looks like to make a GraphQL request. So there's a schema that you define, and then there's queries and mutations that you can send to that schema in order to make requests. So I think it's just easier to see an example of what these look like. So a GraphQL query can be simple or complex. So there's a simple example on the left there. We're just requesting the user. There's no argument. We're asking for the user's first name and the last name and their username. So it's pretty simple. And every GraphQL request is going to be a post request. And this layout of code is just going to be the text of the body. And then on the back end, they're just going to read through that body of the request in order to determine what fields you wanted from the endpoint. But you can have a more complex example like on the right here, where not only are we requesting a user, but users have an association with contacts. And you're able to get a list of contacts with their first name and their last name as well. But in the same request, we're also able to get all of the blog posts that we're interested in showing. And so this is really powerful just for all of those reasons we listed above. It lets you dynamically get that data when you want it and the number of requests that you want it in. Now, the other side of GraphQL is you're able to perform mutations. And so mutations are going to allow you to do updates in your backend systems. Here's an example of passing an argument to a GraphQL request. You can do this with queries or mutations. In this case, we're updating a user. We're going to take a user input object, so that's going to be some kind of JSON object with different fields on it. And then the mutation is going to return a username and a first name and a last name as well. And that's going to be important for some reasons we're going to talk about in another minute here. So it's really simple to make queries and mutations within GraphQL. They're pretty similar to each other. One just requests data, and one is going to be performing updates on that data. And this can be really powerful when you're working with microservices because it allows you to have well-defined, flexible contracts. And when you break out into microservices, you have lots of contracts between lots of services. So this is a really important problem to solve. And so using GraphQL can be a really powerful way to solve this problem instead of the typical REST APIs that we're used to. If you want to learn more about GraphQL, there's tons of great resources on the web as well. So graphql.org has great documentation on using GraphQL. There's this advantages and disadvantages of GraphQL website that I thought was good because it mentions some disadvantages. There are a few. For example, every request is going to return 200. It doesn't really ever give you 404s or things like that. You can still get errors from your GraphQL endpoint, but you just have to handle them in slightly different ways, and that's a learning curve. It's something different that you have to get used to. And then this howtographql.com has some really good tutorials on just how basic GraphQL works as well. All right, so now that we've covered microservices and BFFs and GraphQL, let's talk about how we might go about implementing some of these things within our Elixir applications. And so the tool that we're going to be using for that is called Absinthe. Now, Absinthe is a library that was written to make building GraphQL endpoints super easy in Elixir. That's their logo right there. And if you want to learn more, there's this really great book called Craft GraphQL APIs in Elixir with Absinthe. It is a little outdated with the newer versions of Elixir, but it can still be a good read to get the basics of how to use Absinthe within your Elixir applications as well. So I recommend checking that out. So to get started with GraphQL and Elixir, you're going to need to define a couple things within your code. You're going to need to define your schema, and that's going to include all of your queries and all of your mutations. You're going to need to define your types, and you're also going to have to define your resolvers. And now these can live in different files, which is how I typically see it done, or you could put all this into one file. We're going to walk through each of these with some code examples, though. So here's how you define a schema with Absinthe. So here we have this, and you will, just to note, you will have to do some initial configuration with Absinthe. You're going to have to go add some stuff to the config file. You're going to have to just follow that initial setup, but it's pretty easy to just follow the docs online for that. But once you have that initial setup and you want to actually start building your schema, this is how you do it. So you're able to just specify a field. That field is going to be called user, and then that second argument there is the type. So it's of type user. And we're also saying that it takes in an argument called ID, and that argument is not allowed to be null. And so Absinthe provides a lot of these helper functions so that you can dictate what your schema looks like. You can say if it's not supposed to be null or not. You can say if it's a list of something or not. And it's really flexible. They offer a lot of these things for you to use. And then there's this resolve field. And the resolve is going to be how Absinthe connects its API with the rest of your application. So it's going to take that resolve function and pass certain arguments to it when your GraphQL endpoint is hit. So now let's take a closer look at defining that user type that's after the field on that line there. So this is what our user type looks like. And it's going to have a field with ID. It's going to have a username, a first name, last name, and a list of contacts. Like I said, there's that helper function for a list of, and there's tons of those that they provide. You can dictate what types all of these things are as well. So there's a special ID type, there's a string type, there's integer, there's date and times. There's everything you could ever need, and you can even define custom ones if you want to as well. So once you have your schema and your type set up, then you just need to make your resolver. So this is that piece that's going to connect Absinthe to the rest of your application, where they're going to pass certain arguments to you when those GraphQL endpoints are hit. And it's going to take in 3 different arguments. The first one is a parent argument, and that's just going to let you reference whatever parent field you might have if you have some nested stuff going on. The second one is the one I tend to use the most, and that's just the actual arguments that were passed in. So when we defined here that argument of ID, this is where we're pulling it out. And it's just a map with all the arguments that were passed in. And then the third parameter that's passed in is the resolution. And there's some cool things you can do with the resolution that we're going to talk about in a minute as well. But once you're in here and once you have these arguments, you're really free to do whatever you want within your application to fill that data that you need. And so here, maybe we have some other service called accounts.findUser that goes and reaches out using Ecto into our database in order to query for users and return that user. And then the only thing we have to do is return a tuple, which has the OK and then the user with those fields within a map. And it's that easy to connect our data in that GraphQL endpoint. And I kind of mentioned this a little bit before, but I like to think about the file structure of these things because it can get a little confusing when you're building large GraphQL APIs. And I like to compartmentalize more on the left with all of my mutations, queries, resolvers, and types for a specific idea or concept within my code base, as opposed to grouping it as it is on the right. But you can really do it however you want. I just tend to touch the queries and the resolvers and the types for a user together more instead of touching all of the resolvers at once, or all of the queries at once, or all of the types at once. But that's not all you can do with Absinthe. There's a lot of really cool things that you can do. So you can do nested fields, context, and secure logging, just to name a few. We're not going to be able to cover everything because there's so much in Absinthe, but I just wanted to show a few of these other more advanced features. So when you're defining your type for your user, you can also add a sub-resolver in your user type. So here we have that list of contacts, but say your business grows and the definition of a contact changes. Maybe it just used to be a first and last name, and that was easy enough to just store right there as a list of type contact. But now your contact has become a lot more complex, and they can email these contacts or message them or whatever it may be. So you need to build your own custom resolver for that contact. It's as easy as just adding it with its own argument and resolve function underneath that user type. And the really cool thing about this too is when a user hits that GraphQL endpoint, if they don't ask for the contacts, then that code's not going to be executed. It's just going to execute that code when someone actually requests for the contacts and not otherwise, which is really nice. Let's talk a little bit about context. So that's that. With that third argument, the resolution, into your resolver, there's some cool things that you can do. And one of the coolest ones that's really useful is a context. And so in Elixir, you can build plugs, and you're able to use a plug with Absinthe to build a context for all of your GraphQL endpoints. So maybe you have some kind of token that you're always passing for authentication into your system. Or maybe you always want to know who the current user is in order to determine who's performing actions, if they're allowed to perform that action or not. So by building a plug that looks somewhat like this, you're able to throw that information into the context, which is going to be found on that third parameter. So in this example, we're just grabbing a token from the header, and we're able to then determine who the current user is, and then pass that along on the context. And then we can use that like this within our resolver. And then we're able to leverage Elixir's great pattern matching capabilities here too, because then we can just pattern match on the context and see who the current user is and see if they're admin or not. And if they are, we're able to create the user. But if they're not, then we say that access is denied. And it's really as simple as that to share data between all of our GraphQL endpoints within Elixir using Absinthe. And this is one that I thought was kind of cool as well. It comes with some nice tools that allow you to be more secure in your applications. So in your config file, you can say what variables you want to filter. So maybe you're using some kind of logger so that you can track metrics within your application. You want to see how often certain endpoints are called, whatever it may be. But you don't want to be logging sensitive data about your users, right? So you don't want to be logging maybe tokens they have, or if they have to pass their social security number. You don't want to have your engineers have access to that within your logs. And so with Absinthe, you're able to have this filter variables filled in the config that just filters those out of your logs, and you don't have to do anything with it. And I think they actually pre-filtered password without you ever having to add anything yourself, which is pretty cool too. And so there's great ways that you can be secure by using Absinthe as well. And that's not all. There's so much that Absinthe can do for you when you're writing GraphQL and Elixir. It automatically converts the casing, which is really nice because with JavaScript, everything tends to be camel cased, but with Elixir, everything tends to be snake cased. And that can be a real pain to have to deal with, and they just take that pain away by automatically converting the camel case to the snake case for you, which is really nice. You can use input object types. So just like we define that user type, you can also define an input object type, and that's going to take in data as an argument into your GraphQL endpoint. And so like that mutation that we saw earlier with the user, that would be an input object type, so that you don't have to pass in 50 different fields to update your user. You're just able to pass in one single object with the right fields on it. And one thing to keep in mind is if you are maybe using something like Apollo on the front end, is it's really good to have your mutations and your queries give similar responses. And that's because it's going to let you leverage caching on the front end. If you have a user and you're updating it and you're using something like Apollo and you make a mutation to that user, you're able to leverage an optimistic update. And then when that response actually comes back, you're actually able to leverage that caching as well when you have similar queries and mutations when they give similar responses. So that's something to keep in mind as well as you're writing these GraphQL endpoints. And here's some links that you can use to learn more about Absinthe. Absinthe-GraphQL is great, just their documentation. They also have their hex package docs and everything that you can look at. They also have an Absinthe tutorial similar to that GraphQL book that I mentioned. It has some issues with the newer versions of Elixir, but I still think it could be helpful to just go dig through the repo, kind of see how they set up their schemas, their queries, their resolvers, and everything like that, just to get a basic understanding of how that flow works throughout your app. And then howtographql.com, that one I mentioned before, also has a great GraphQL Elixir introduction that you can use as well. So I recommend checking out those resources. All right, so we talked a lot about BFFs earlier, so I want to just talk a little bit about how you might go about implementing a BFF in Elixir using Absinthe. And it's really not anything crazy. Really, you're just proxying a request through your BFF to another service, maybe doing some translation in between. But let's just imagine that we have some other service that our BFF is talking to. And we build some kind of helper function like this one here, where we can pass in a query, the field, so it might be users, it might be blog posts, the parameters that our BFF received from the front end, and maybe some options that's going to have some stuff like the context on it that we can use. And then we just are able to perform that query, maybe by using some kind of HTTP client, maybe using HTTP poison, something like that. And then we're able to call that service like this. We can just hard code that query into our Elixir code and then make that query against the other microservice that has that data for us. And this is where that problem of code duplication is going to come in, because we're going to have duplicative schemas here. The BFF and the other microservice might have the exact same schema as each other. And right here, we're just hard coding this in, and that has the negative effect of if the front end is only requesting the username and they don't care about first name and last name, this BFF is still going to request the first name and the last name from that other microservice. It's not going to necessarily pass it along, but we're still getting more data than we need, which kind of goes against one of the benefits of using GraphQL. So that's just something to keep in mind. One other cool thing that we've done at Podium with BFFs is re-leveraging change sets from Ecto in order to do some validation on data coming through. So if we have our BFF and it's making a request to some other microservice, then we can pipe that response through a change set in order to do some validation to make sure that the data coming from that other microservice is what we expect it to be. And that can be really useful just for some bulletproofing on our BFF as well. So for example here, if we define a change set, it's that same user object. It has a username, first name, last name. We define the embedded schema there. Then you'd be able to leverage that somewhat like this. So if we have this update user function that's going to take in some arguments and some options like the context, we can go out, we can actually perform that user.update user, which would be calling to something like this. And then as soon as we get that response, we can just pipe it into that change set. So here, there's a helper function that we've built that formats that response by piping it through our change set. And I also thought it might be helpful to see how you might be able to use the context here as well. You're able to grab that auth token off the context and leverage that third parameter as well in the resolver that we talked about earlier. Now, we're still working through some issues with BFFs at Podium too. Like I said, we don't like that we have to duplicate these schemas in this way by hard coding them in our Elixir code. But there is one cool thing that Absinthe offers that you can leverage, which is called absinthe.resolution.project. So when your GraphQL endpoint is hit, you're able to project, and you'll get something that looks like the above there with the user, the ID, and the name. And so you're able to actually see what fields they requested and what subfields they requested. And that can help if you're able to. We have some examples of this in our BFFs as well, but it's a little too big to show here. But you're able to pull these out to more dynamically make those requests and only request from the BFF to the other microservice what your UI requested to your BFF. We have run into some issues with more nested things when using this pattern. And so that's a future project that we want to improve. We want to keep working on our BFFs to have less code duplication, to have better proxying of the requests. And if this interests you in any way at all, then come talk to us. Come help us solve these problems at Podium. Like I said, we're all wearing the shirt today. You can come talk to us. You can go to our booth. We would love if you have any ideas for us or any feedback on this kind of architecture to just discuss these ideas with you. And I think that pretty much sums up most of what I wanted to talk about today. And let's just review those key takeaways again, just keep it fresh in your mind. So I hope that you've been able to see a little bit how microservice architecture can benefit your organization, how it might help you improve things and how you structure things. I hope you have a better understanding of the backend for front-end architecture pattern and how you might leverage that to have a better experience with mobile development, with building your UIs, with managing less contracts on the front end. I hope that you've been able to see why you might want to use GraphQL for communication, especially between your microservices, and how you can leverage that technology to really up your microservice game. And then I hope that you've been able to see some examples of how you would leverage this with Elixir using Absinthe, how you might create a BFF in Elixir as well. And if you're interested in reviewing any of this or seeing those references, we actually just launched a new Podium.engineering blog that you can check out. There's not a ton on there right now, but we hope to keep posting more, and we love Elixir at Podium, so I'm sure there'll be more Elixir articles to come. And like I said, there's references from this talk there as well. And I just wanted to give some credit to some of the different references I used throughout this talk for some of the images and stuff like that. And then if you're interested in reaching out to me personally, here's my LinkedIn, my GitHub, and my Twitter. Feel free to reach out. I'd love to chat about these ideas with you and learn more about maybe how your architecture is patterned, and we can have discussions, whatever. All right, and then we have a little bit of time for Q&A.